Before dawn, a forest path glows faintly with dew, and the air holds a cool breath of soil. A field notebook snaps open under the beam of a small headlamp. You observe a researcher kneeling beside a pale ring of caps. She brushes aside moss, revealing a quiet surprise. Slender stems are only the brief surface of something vastly larger. Beneath leaf litter, hyphae have stitched a lattice through roots and stones. This living loom trades, signals, and waits. The paradox feels. Immense plants are the scenery, but fungi choreograph the scene. When a branch falls, enzymes wake. When drought comes, partnerships tighten. When night deepens, a low logic continues its work. In ancient stories, such circles were thresholds and warnings. In the modern lab, their arcs map chemistry moving outward like slow ripples. An old cedar leans above the ring, its roots threaded with mycelium. This network ferries minerals for sugar, resilience for light. A moth taps a gill. A dust of spores rides a curve of air. The notebook fills with quick sketches, gill spacing, cap texture, the dark print forming on paper. You hear rain far up in the canopy and feel a question settle: how far does this network run? And where does one body truly end? News headlines measure forest loss in hectares. The ground below tallies connections in filaments and exchanges. Somewhere on another ridge, honey fungus shoulders through deadwood, kilometers long and centuries old. Elsewhere, a truffle perfumes the soil until a boar arrives. Partner and plow in one. It is as if the earth were thinking in threads. Every root learns the language by touch. This quiet exploration guides you into the world of mushrooms, an odyssey of 100 relaxing discoveries from across the globe. Step softly, and let the story unfold at the tempo of rain. Beneath the quiet forest floor, an intricate pulsing web of mycelium resides. This hidden architecture forms the true body of many fungi, including the mushrooms you observe. A single cubic inch of healthy forest soil can hold miles of these delicate, branching filaments, tirelessly exploring their subterranean realm. Imagine these threads as the forest's slow thoughts, tracing pathways of nutrients and signals in the dark. Ancient folklore once named these intricate patterns fairy handiwork. Researchers still quietly debate whether cooperation or competition best explains patterns recorded in field plots. Exhale, picture the dappled leaf shade, and feel the slow rain. Let this silent, persistent exchange linger before the next quiet turn. You might have considered the vastness of fungal networks, a hidden world unfolding beneath your feet. Now, picture an organism so immense it spans entire forests. A quiet engineer shaping the very ground you walk upon. Deep within Oregon's Malheur National Forest, a single times armillaria, solidipes times mycelium, stretches across 2,200 acres. This colossal honey mushroom network, often called the humongous fungus, weighs an estimated 35,000 tons, making it the largest known organism by area on Earth. Its intricate mycelial threads, finer than human hair, weave through the soil, a silent internet exchanging nutrients and signals between countless trees. Researchers estimate its age at over 2,400 years, a testament to its elegantly persistent life. Folklore once named such unseen traces fairy handiwork, a magical touch on the forest floor. Yet, this giant is not merely a benign presence. Its slow, persistent spread can also act as a subtle pathogen, influencing the health and decay of its arboreal neighbors. Scientists still debate whether its vast expansion is a triumph of cooperation within its own clones or a relentless competition for resources. Exhale. Picture leaf shade and slow rain. and let the quiet persistence of this underground world linger. You have explored the visible wonders of mushrooms, their brief appearances above ground, but beneath your feet, a quiet, practical elegance persists. This unseen world centers on mycorrhiza, a partnership between trees and fungi. Imagine meters of fungal threads, or mycelium, in a single handful of soil, reaching where roots cannot. The fungi engineer nutrients and water from the earth, delivering them to trees. In exchange, the trees offer life-giving sugars from their leaves. Researchers still debate if this ancient bond is pure cooperation or a subtle, persistent competition, a slow negotiation unfolding in the dark. Picture leaf shade and slow rain. Let the profound exchange beneath the forest floor linger in your mind. As twilight deepens, you might sense the forest holding its breath, preparing to reveal another quiet marvel. Among damp leaves and decaying wood, certain fungi ignite, casting a soft green light. This ethereal glow, a cold luminescence, emerges from a chemical reaction within their cells, much like a firefly's beacon. For centuries, these luminous patches inspired tales of foxfire or fairy handiwork, whispers in the dark woods. Scientists now debate whether this light primarily attracts insects to disperse spores or deters nocturnal predators. This subtle illumination feels like the forest itself, thinking slowly in the dark, line by line. You observe the quiet, practical persistence of these living lights. A gentle, elegant pulse in the deep night. You sense the quiet persistence of networks beneath your feet, a hidden world speaking in subtle currents. Truffles, those prized fungal fruits, release an array of volatile organic compounds, creating an aromatic map in the soil. Their unique perfume can be detected by trained animals from many meters away, guiding a delicate, ancient hunt. This subterranean language of scent acts like an invisible broadcast, signaling maturity and attracting dispersers. Some compounds mimic animal pheromones, a clever fungal strategy to ensure their spores travel far beyond their buried origins. Scientists still unravel this precise chemical symphony. They debate whether these scents primarily attract specific animals or merely mark territory in a complex underground dialogue. Imagine the forest floor, a silent tapestry, woven with these potent, unseen whispers. Let the subtle, earthy notes settle into your awareness, a quiet turn in the dark. You might not often consider the invisible architecture of a forest's breath. The air itself carries a silent testament to fungal ingenuity. Each mushroom releases millions of microscopic spores. A single mature cap can eject billions over days, a continuous, tiny eruption. This dispersal is no accident. Intricate gill structures beneath a cap are precisely engineered. Their aerodynamic curves channel air currents, facilitating efficient spore launch. Researchers still debate if this spacing evolved for cooperative release or from intense competition for optimal dispersal lanes. This subtle tension plays out in every forest plot. Folklore once called these ethereal drifts fairy dust, explaining new life after rain. Picture the quiet persistence of these tiny architects, shaping the very air you breathe. Line by line, your senses often lead the way, guiding you through the forest's quiet offerings. The beloved porcini, Boletus edulis *, stands as a testament to rich, earthy flavor, coveted across continents. Its dense, meaty texture makes it a prized culinary ingredient, a true forest jewel, engineering nutrients into delectable form. For centuries, foragers in Italy have guarded their secret spots, passing down knowledge of these little pigs through generations. Ancient Roman texts even mention their appreciation for thyme's Suillus *, a close relative, highlighting a deep historical connection to this fungal delicacy. This deep-rooted cultural significance underscores how mushrooms shape human traditions, weaving them into the fabric of daily life. You might recall its distinct aroma, a promise of umami, long after the rain has settled the forest dust. Beneath the dappled light, another golden treasure emerges, a delicate trumpet of the woods. Chanterelles, particularly Thymes Cantharellus cibarius **, offer a fruity, peppery note, a stark contrast to the porcini's earthiness. They form mycorrhizal relationships, an intricate dance with tree roots, exchanging vital nutrients. Imagine the mycelial network as an invisible underground river, channeling resources between fungi and flora. This silent partnership allows the chanterelle to flourish, transforming the forest floor's hidden economy. Their apricot tangent-like scent, a subtle invitation, drifts on the humid air. Guiding you closer, the forest whispers their location, a secret shared between the soil and the discerning eye. From wild forest floors, our journey shifts to cultivated spaces, where ancient wisdom meets modern practice. The shiitake mushroom, Lentinula edodes *, originating in East Asia, now graces kitchens worldwide, valued for its robust flavor and firm texture. Its cultivation dates back over 1,000 years, a testament to its enduring appeal. Early cultivation methods involved felling trees and waiting for spores to land, a slow, natural process. Today, controlled environments optimize growth, yet debates continue regarding the nutritional nuances between wild-harvested and commercially grown varieties. Some argue wild shiitake possess a deeper, more complex flavor profile, a subtle difference for the discerning palate. You consider the quiet persistence of its journey, from ancient logs to your modern plate, a global culinary ambassador. Beyond these celebrated few, a vast tapestry of edible mushrooms awaits discovery, each with its own story. Many lesser-known species contribute significantly to local diets and traditional medicine, offering unique nutrient profiles. They are natural engineers of health, providing vitamins, minerals, and compounds that support well-being. Modern research increasingly uncovers novel bioactive compounds in these diverse fungi, hinting at untapped pharmaceutical potential. Scientists observe how compounds like beta-glucans, abundant in many edible mushrooms, bolster immune responses, a field of ongoing study. This quiet revolution in understanding reveals their profound impact. You sense the intricate web of benefits, a subtle offering from the fungal kingdom woven into the fabric of life. The forest breathes, a silent orchestra tuning its instruments, preparing for the next movement. The allure of wild foraging calls to an ancient instinct, connecting you directly to the earth's bounty. However, identifying edible species requires careful knowledge and respect for nature's subtle warnings. A single mistake can carry severe consequences, underscoring the delicate balance of this ancient practice. Throughout history, communities developed intricate systems of knowledge, often passed down through oral traditions and strict apprenticeships. Today, DNA barcoding offers new precision in identification, yet the human eye and accumulated wisdom remain paramount. The subtle differences between a delicious morsel and a toxic mimic are often debated even among seasoned experts. You reflect on the quiet discipline needed, the patience and humility required to truly understand the forest's language. Beneath the visible fruiting bodies lies the true architect, a hidden network of threads. The mycelium, meters of it in a handful of soil, acts as the primary body of the fungus, a vast, unseen engineer of flavor and structure. It quietly processes nutrients, forming the very essence of the mushroom. Consider this subterranean web, as the forest's slow-thinking brain, borrowing threads to communicate and sustain life. Modern gourmet cultivation now explores mycelial fermentation, using these networks to create unique flavors and textures in plant-based foods, a fresh application of ancient biology. This quiet innovation expands our culinary horizons. You feel the subtle pulse of this hidden world, a persistent hum beneath your feet, crafting the tastes you cherish. From silent forest floors, mushrooms step into the vibrant realm of human creativity and tradition. Artisans and chefs transform these humble ingredients into culinary masterpieces, elevating their unique textures and aromas. This process turns simple sustenance into an experience, a quiet ritual. Folklore once named their sudden appearance fairy handiwork, imbuing them with mystical qualities. Today, chefs meticulously pair their earthy notes with other ingredients, turning scents and colors into rites of flavor. The quiet sizzle in a pan, the release of their deep aroma, becomes a moment of subtle alchemy. You taste the echoes of ancient forests, a story passed down through flavors, elegantly persistent. You observe how the forest floor quietly persists, its damp soil often revealing forms of striking yet dangerous beauty. Among these, the genus Amanita stands as a potent reminder that not all beauty is benign. A single cap of species like the death cap, asterisk, Amanita phalloides asterisk, holds enough toxins to silence several human lives. Their elegant caps often mirror edible varieties, which has historically led to tragic misidentifications. This blurs the lines between life-giving sustenance and fatal poison. Folklore once wove tales of fairy handiwork around such forms, unaware of the silent, potent chemistry within. Even experienced foragers sometimes face the subtle challenges of distinguishing these deadly lookalikes from their harmless counterparts. This is a testament to nature's intricate, often deceptive patterns. Researchers continue to map the genetic differences, yet visual cues remain the primary perilous guide. You consider the delicate balance between wonder and caution. Let the forest's quiet lessons about hidden dangers settle like slow rain upon your thoughts. The forest often thinks slowly, through hidden threads. You might notice subtle tapestries clinging to ancient stones or tree bark. These quiet formations are lichens. They represent a remarkable partnership. A fungus provides shelter, while algae, or cyanobacteria, offer sustenance through photosynthesis. It is a miniature ecosystem, a living mosaic spread across the world's surfaces. Researchers still debate the exact nature of this bond. Some see it as a controlled symbiosis, almost a fungal farming of algae, rather than a purely equal marriage. This intricate dance allows lichens to colonize extreme environments. They thrive from polar tundras to scorching deserts, slowly transforming barren rock into fertile soil. Their silent, persistent work, often unnoticed, subtly reshapes the world beneath your gaze. Let this quiet persistence settle. You recall how life often finds unseen pathways, a quiet persistence beneath the forest floor. Among these fungal engineers, the Cordyceps genus orchestrates a remarkable transformation. It targets specific insects with chilling precision, turning them into temporary vessels for its own growth. Imagine a tiny ant, compelled to climb a stem. It clamps its mandibles onto a leaf just before its life fades. From this fixed point, a slender fungal stalk emerges from its head, dispersing spores. This silent, intricate process, sometimes known as zombie ant fungus, has been observed for centuries. It represents a subtle mechanism regulating insect populations. Researchers still explore the chemical signals allowing such exact control. You sense the forest's deep, slow breathing in these hidden exchanges, a persistent, ancient dance. You often glimpse ancient stories in the quiet persistence of life. Consider that fungal fossils whisper of networks thriving over 1 billion years ago. Long before the first forest giants stood tall, these ancient threads, like silent engineers, began shaping the very soil beneath your feet. For eons, they wove intricate patterns, a slow, dark thought of the forest floor, creating the conditions for future life. Some researchers still debate whether these deep time patterns suggest ancient cooperation or fierce competition among early fungal forms. Yet, ancient folklore once simply named these subtle traces fairy handiwork. A simpler explanation for such persistent magic. Allow this vast, quiet history to settle, like slow rain on ancient leaves, before the world shifts once more. You recall how the forest floor seems to breathe, a subtle, unseen pulse of life and decay. Among the most potent agents of this decay are white rot fungi, masters of lignin breakdown, the tough polymer that gives wood its strength. This complex molecule was once considered almost indestructible by other organisms. These specialized mushrooms, like certain oyster mushrooms or artist's conch, deploy an arsenal of powerful enzymes. They effectively bleach wood, leaving behind pale, soft fibers, rich in cellulose. This biological marvel emerged hundreds of millions of years ago, fundamentally reshaping ancient ecosystems by preventing endless wood accumulation. Imagine the slow, patient work of these hidden architects, turning solid timber into breathable soil. Yet, another decay pathway sculpts wood into a different form, equally vital for the forest's health. Brown rot fungi, though less diverse than white rot, specialize in consuming cellulose and hemicellulose. They leave lignin largely intact, resulting in a characteristic, crumbly, brown residue. Picture a fallen log that, when touched, crumbles into neat, cubical pieces. This cubical rot is their signature, a process that enriches the soil with lignin-derived compounds. Some scientists ponder if this lignin residue actually benefits soil carbon sequestration. This distinct method of decomposition offers a different kind of gift to the earth. The very existence of these wood-eating fungi tells a deep story about Earth's past. For millions of years, during the Carboniferous period, wood accumulated, forming vast coal deposits. This was before white rot fungi evolved their lignin-degrading abilities. The arrival of efficient lignin decomposers around 300 million years ago marked a turning point. It dramatically reduced the burial of plant matter, forever altering the global carbon cycle. Researchers still debate the exact timing and the cascade of ecological effects this fungal innovation triggered. You sense the immense geological scale of their quiet, persistent work. Beyond the wild forest, these microscopic architects touch human structures in profound ways. Brown rot fungi are often the primary culprits behind timber decay in homes and wooden structures. They can reduce the structural integrity of wood by up to 70%, long before visible signs appear. Imagine a hidden termite colony, but instead of insects, it's a silent fungal network. They extract the cellulose, leaving the lignin framework brittle and prone to sudden collapse. This silent erosion requires careful monitoring in historic buildings. Their preference for cellulose shapes the longevity of our wooden legacies. The forest whispers its ancient secrets through these slow, deliberate transformations. The rich, earthy scent of a healthy forest floor is, in part, a testament to their labor. Decomposing wood, broken down by white rot and brown rot fungi, releases vital nutrients back into the soil. These recycled elements become available for new plant growth. Think of the forest as a grand, circular economy, where nothing is truly wasted. The fungi act as diligent custodians, ensuring the continuous flow of life-sustaining minerals. You might even catch the subtle, sweet scent of decaying wood, a fragrant signature of their work. This quiet, fragrant alchemy fuels the next generation of trees and plants. Their powerful enzymes, honed over millennia, hold promise for modern challenges. Scientists are exploring the use of white rot fungi for bioremediation, deploying them to break down pollutants. Their lignin-degrading enzymes can also dismantle complex synthetic chemicals. Imagine a microscopic cleanup crew, tackling oil spills or industrial waste sites. Some species show remarkable ability to degrade persistent organic pollutants, including certain plastics and pesticides. This emerging field offers a natural, sustainable approach to environmental healing. These ancient decomposers might hold keys to a cleaner future. The decay they instigate is not merely destruction, but also creation. As fungi decompose wood, they create cavities and soften timber, providing essential habitats for countless organisms. From insects to small mammals, many rely on these fungal transformations. Picture a decaying log as a bustling apartment complex, with each fungal-created space offering shelter or food. Beetles bore into the softened wood, salamanders hide beneath the peeling bark, and birds nest in hollowed-out sections. It is a testament to life emerging from breakdown. The slow work of decay nurtures new life in unexpected ways. The interactions between different fungal species within a single log are a complex dance. Researchers still debate whether cooperation or competition best explains the patterns observed in fungal decay. Mycelial networks can overlap, creating zones of intense biochemical warfare or synergistic action. Imagine a microscopic battleground where different fungal armies deploy enzymes as weapons, vying for resources. Yet, sometimes, their combined efforts lead to more efficient decomposition than either could achieve alone. This intricate balance remains a fascinating area of study. The quiet drama of their underground world continues to unfold. A silent orchestra plays on, each note a deliberate step in nature's grand design. The true scale of their recycling effort often remains hidden from view. A single handful of forest soil can contain kilometers of mycelium. These thread-like structures tirelessly infiltrate wood, extending their reach far beyond the visible mushroom. Consider the sheer persistence of these microscopic threads, weaving through the earth, seeking out nutrients. They are the true engineers, silently dismantling and rebuilding the forest floor, one molecule at a time. The visible fruiting body is merely a fleeting signal of this vast, unseen enterprise. Their quiet industry beneath the surface ensures the continuous flow of life's essential elements. The subtle transformations wrought by decay can even influence human senses and traditions. While some fungi cause decay, others, like certain edible species, contribute unique flavors as they break down wood. Think of the earthy notes in shiitake mushrooms, often cultivated on logs. The artisans of old, and even modern chefs, understand this delicate balance. The specific enzymes at work can create nuanced aromas and textures, transforming a simple substrate into a culinary delight. Folklore once named these traces fairy handiwork, appreciating the invisible forces. Their silent work enriches not only the soil, but also our palates and imaginations. Beneath the quiet surface, a silent transformation unfolds, unseen by hurried eyes, yet deeply impactful. Mycelial networks, the intricate, root-like structures of mushrooms, possess a remarkable capacity to cleanse polluted soil. They act as nature's tireless engineers, dismantling complex toxins into simpler, less harmful compounds. You might picture a vast, living filtration system, patiently processing the remnants of human activity, much like a slow, deliberate river purifying its waters. This gentle process, termed mycormediation, offers a hopeful path to heal damaged landscapes. Scientists observe how the mycelium uses powerful enzymes, initially evolved to break down wood, now applied to industrial pollutants. This elegant repurposing of ancient biological tools continues to fascinate researchers. The Earth breathes a little easier through these hidden, persistent efforts, a quiet testament to fungal ingenuity. The unseen threads possess a remarkable appetite, extending their reach to unexpected substances. Certain mushroom species, like the common oyster mushroom, effectively degrade petroleum hydrocarbons and various persistent pesticides. Their hidden networks transform environmental burdens. Imagine a forest floor quietly consuming an oil spill, turning a toxic slick into fertile ground. This ability stems from their powerful extracellular enzymes, designed to dismantle tough lignin in wood, which coincidentally share structural similarities with many pollutants. The process is a quiet alchemy, transforming what seems permanent into something less menacing. Academic debates sometimes center on the long-term stability of these degraded compounds in complex ecosystems. You sense the slow, deliberate work of nature's hidden hands, weaving renewal. Beyond organic pollutants, other formidable challenges await the gentle, persistent fungal touch. Some fungi can absorb and sequester heavy metals, such as lead, cadmium, and even radioactive isotopes, from contaminated sites. This remarkable process concentrates dangerous elements. This method, known as myco-extraction or biosorption, pulls harmful substances from the soil, trapping them within the fungal biomass. While not breaking them down, it concentrates them, allowing for safer removal and disposal, or sometimes even recovery. You might picture a living sponge, slowly soaking up the invisible poisons. Folklore sometimes hinted at mushrooms growing in strange places, perhaps unknowingly observing this ancient process. A subtle cleansing unfolds beneath your feet, unseen yet profoundly impactful. You might not see them, yet a silent alchemy unfolds in kitchens and cellars across the globe. Billions of single-celled fungi, known as yeasts, perform this unseen magic, transforming simple sugars into the very essence of bread, beer, and wine. A single gram of active dry yeast can contain 20 billion living cells, each a tiny factory of fermentation. For millennia, long before microscopes revealed their true identity, ancient cultures harnessed these invisible engineers, attributing rising dough or bubbling wine to divine intervention or natural spirits. Imagine the slow, patient work of these microscopic architects, weaving flavor and texture into existence. Like mycelial networks beneath a forest, their quiet industry shapes countless daily rituals, a persistent hum beneath our world's surface. You sense their subtle presence, a quiet reminder of hidden forces. You have drifted through verdant landscapes where life unfolds in endless, gentle cycles. Now, let your mind wander to the edge, where existence itself becomes a profound act of patience. The desert, a vast canvas of sand and rock, appears to hold little room for delicate life. Yet, hidden beneath the sun-baked crust, specialized fungi lie dormant, sometimes for decades. They wait for the rare, fleeting moisture of a desert rain, a signal to awaken. These organisms are masters of survival, their mycelial threads forming intricate networks that can withstand extreme desiccation and intense heat. They can lose up to 95% of their water content and still revive, a remarkable feat of cellular engineering. This quiet resilience challenges our common notions of fragility, hinting at a deeper, unseen world. Imagine the slow pulse of life, patiently holding its breath through the longest drought. Among the most prized fungi, truffles are usually associated with damp, ancient forests. However, desert truffles, like the Times terfasia times and Times tiermania times species, thrive in arid lands across the Middle East and North Africa. They form symbiotic relationships with desert plants, exchanging vital nutrients in the harsh soil. These subterranean treasures are often harvested after rains, located by the subtle cracks they create in the earth, or by trained animals. Their earthy aroma and distinctive flavor have made them a culinary delicacy for centuries, weaving them into local traditions and livelihoods. This ancient practice of foraging highlights a deep, practical connection to the desert's hidden bounty. You can almost taste the subtle mineral notes carried by the desert wind, a whisper from the deep earth. You might picture bioluminescent fungi glowing in a humid tropical rainforest at night. While rare, some desert-adapted fungi have been observed to exhibit a faint luminescence, though often less vibrant than their tropical cousins. This subtle glow might serve various ecological purposes, still largely debated by scientists. Perhaps it attracts specific nocturnal insects for spore dispersal. Or perhaps it is a byproduct of metabolic processes, an internal light that simply exists. The soft, ephemeral light in the vast desert darkness adds a layer of quiet mystery, a fleeting beacon in an otherwise stark landscape. It hints at communication beyond our easy perception. Close your eyes and picture a faint, cool light pulsing softly in the deep quiet of a desert night. The very survival of many desert plants hinges on unseen underground partnerships. Mycorrhizal fungi form extensive networks beneath the desert floor, connecting plant roots and vastly increasing their access to scarce water and nutrients. These fungal threads can stretch for meters in a handful of soil. This intricate web acts as a living pipeline, drawing moisture from deeper soil layers and sharing it among various plants, creating a resilient ecosystem. Some researchers suggest these networks also facilitate chemical signaling, allowing plants to warn each other of threats, a silent conversation in the dark earth. It is a profound example of cooperation in extreme conditions. Feel the slow, quiet hum of countless exchanges, a hidden economy beneath your feet. The desert breathes its ancient secrets, a slow unfolding of life's quiet ingenuity etched into the very fabric of the earth. Wind and erosion constantly reshape the desert, threatening to strip away precious topsoil. Certain desert fungi, particularly those forming biological soil crusts, play a crucial role in stabilizing these fragile environments. Their dense mycelial mats bind sand and soil particles together. These living crusts, often dark and textured, prevent erosion and enhance water infiltration, transforming barren ground into a more hospitable substrate for other life. They are slow-growing, sometimes taking decades to fully establish, yet their impact is profound and long-lasting. This subtle engineering helps to anchor the landscape, slowing the desert's relentless drift. You sense the quiet, steady grip of unseen hands holding the shifting sands in place. Surviving the scorching desert sun requires extraordinary cellular defenses. Many desert fungi produce unique heat shock proteins and osmolytes, compounds that protect their cellular structures from damage under extreme temperatures. They can thrive where most other life forms perish. These biochemical adaptations allow them to endure daily temperature swings of 30 degrees Celsius or more, a testament to their remarkable physiological resilience. Scientists study these mechanisms, hoping to unlock secrets for human applications, from drought-resistant crops to new medical therapies. It is a quiet lesson in enduring the impossible. Picture the silent, molecular dance of protection, unfolding deep within each fungal cell. Every drop of water in the desert is a precious commodity, fiercely conserved. Some desert fungi possess specialized structures that act as micro-reservoirs, efficiently capturing and storing moisture from dew, fog, or sparse rainfall. These intricate forms maximize water collection. Their hyphae can absorb water directly from humid air, a process known as atmospheric water uptake, allowing them to hydrate even without direct precipitation. This ingenious adaptation ensures survival in regions where rain might fall only a few times a year, turning fleeting humidity into a lifeline. It is a quiet, practical mastery of an unforgiving world. You observe the elegant efficiency, a whispered promise of life in the barest moisture. Across millennia, humans have found meaning and sustenance in the desert's hidden life. Ancient cultures in arid regions often incorporated desert fungi into their folklore, medicinal practices, and spiritual rites. These stories speak of their mysterious appearance after rain. Some indigenous traditions consider the sudden emergence of desert truffles or puffballs as gifts from the sky, symbols of renewal and abundance in a harsh land. Artisans once used their subtle pigments for dyes, while healers valued their perceived properties. These deep, human connections underscore the fungi's enduring role far beyond mere biology. Let the echoes of ancient voices carry you, connecting earth and sky through these quiet, persistent forms. The desert holds its breath, then releases a silent symphony of growth, a testament to life's unwavering resolve. The struggle for resources defines life in the desert, yet cooperation also plays a vital role. Researchers still debate whether cooperation or competition best explains the patterns observed in desert fungal communities. Both strategies are evident in their complex interactions. Some fungi compete fiercely for limited water and nutrient patches, producing antimicrobial compounds to ward off rivals. Others form intricate alliances with plants and even other microbial life, sharing resources and defense mechanisms. This dynamic tension, a constant negotiation between self-interest and mutual aid, shapes the very structure of the desert ecosystem. You ponder the delicate balance, the intricate dance of survival played out in the quiet dust. Even in the starkest environments, life's cycles must continue. Nutrients return to the earth. Desert fungi are essential decomposers, breaking down dead plant material and animal remains that fall upon the arid soil. They recycle vital elements, ensuring the continuity of life. Without these tireless engineers, the desert floor would accumulate organic matter, locking away precious carbon and nitrogen. Their slow, persistent work transforms decay into renewal, making nutrients available for new growth. This quiet, fundamental process underpins the entire desert food web, a hidden engine of regeneration. Observe the slow, steady turning of the Earth's quiet gears, transforming what was into what will be. You might imagine life struggles in the highest, coldest places, where the wind bites and winter lingers long. Yet, certain mushrooms defy these conditions, thriving above the tree line and in polar regions. These hardy species adapt to extreme temperatures and short growing seasons, some emerging for mere weeks each year. Consider the snow fungus, Tremella fusiformis *, often found in Arctic areas, its gelatinous form holding moisture against dry, cold air. It waits beneath snowdrifts, a hidden engineer of nutrients, ready to decompose matter as the brief thaw arrives. This quiet persistence echoes through the vast, open landscapes, a slow, deliberate rhythm of life. You sense the ancient wisdom held within their mycelial networks, patiently weaving through frozen earth. In these stark environments, where resources are precious, every living thing holds deeper meaning. Indigenous communities have long harvested specific alpine and Arctic mushrooms, understanding their seasonal gifts. For instance, the prized Times Boletus edulis asterisk, or porcini, finds its way into subalpine forests, sought for its rich, earthy flavor. Arctic peoples once dried certain species for winter sustenance, turning fleeting summer gifts into lasting provisions. This practical wisdom, passed down through generations, highlights a profound respect for nature's sparse bounty. You taste the quiet history in their earthy flavors, connecting distant past to present moment. A subtle thread woven through time. Beneath the frozen ground, an unseen world hums with quiet, persistent activity. Mycelial networks in alpine soils are vital engineers for nutrient cycling, even in the harshest conditions. They break down organic matter, releasing essential nutrients for other plants, enabling life to flourish during short growing seasons. Researchers still debate whether cooperation or competition best explains these complex underground relationships. Some evidence suggests a delicate balance, where fungi might share resources with specific plants, while others vie for limited space and sustenance. You imagine these invisible threads, slowly thinking in the dark, orchestrating life's quiet dance, a silent symphony beneath your feet. Life in extreme environments often finds ingenious ways to provide refuge, even in the smallest forms. Certain bracket fungi, tough and persistent, offer temporary shelter for small insects in alpine environments. Their sturdy forms provide a brief respite from harsh winds or sudden snowfalls, a tiny haven in a vast expanse. Beyond physical shelter, some Arctic fungi release subtle chemical signals into the air or soil. These unseen communications might warn other organisms of environmental changes or attract specific partners. The forest, in its own way, borrows threads to think slowly, line by line. A quiet, deliberate process. You feel the subtle exchange, a language spoken without words, a quiet dialogue across the landscape, barely perceptible. The air thins, the light shifts, yet life persists in intricate, unseen patterns. A quiet hum resonates from the earth, a steady pulse beneath the ancient ice. Beyond mere survival, these quiet organisms have long inspired human creativity and reverence. Artisans once turned the scents and colors of certain alpine mushrooms into rites and dyes, imbuing them with deeper meaning. Consider the vibrant pigments extracted from lichens, which involve a crucial fungal component used in traditional textiles. Imagine the careful process, extracting deep reds or subtle yellows from mountain flora, weaving them into ceremonial garments. These ancient practices elevate the natural world into something sacred, a bridge between the practical and the spiritual. Connecting communities to their environment, you trace the delicate patterns, sensing the reverence held within each hue. A silent story unfolding across generations. Even in remote corners of the world, patterns are subtly shifting, altering ancient rhythms. Researchers are observing changes in alpine and Arctic mushroom seasons, directly linked to climate warming. Earlier thaws or altered precipitation patterns can impact fruiting times and species distribution in these fragile ecosystems. Some fungi might expand their range into new territories, while others, highly specialized for cold, face new challenges, their existence finely balanced. This delicate equilibrium, tuned over millennia, now responds to human-scaled changes. Scientists continue to monitor these shifts, meticulously recording subtle alterations in field plots. You watch the invisible currents of change, a slow narrative unfolding across the vast, silent landscapes, a story whispered on the wind. High above the forest floor, tropical canopy fungi conduct their quiet, practical work, often unseen by you below. These fungi act as unseen engineers, recycling vital nutrients from decaying leaves and branches hundreds of feet above the ground. A single mycelial network might stretch for meters through humid air. It transforms dead matter into life-sustaining energy for the canopy ecosystem. Ancient folklore sometimes attributed these high-dwelling traces to fairy handiwork, unseen architects weaving threads of life and decay. Artisans once sought their unique scents and subtle colors for ceremonial dyes or rites. Researchers still debate whether cooperation or competition best explains their patterns in field plots. This remains a silent struggle or shared endeavor, unfolding in the arboreal darkness. Exhale slowly, picturing the dappled leaf shade and the feel of slow rain touching these hidden networks. Let this quiet exchange linger, a persistent pulse in the green heart of the world, before the next gentle turn. You might sense the quiet ripple of unseen forces shaping the forest floor. Sometimes, these deep connections reveal themselves in visible patterns. You observe how certain mushrooms emerge in an ever-widening circle, commonly known as a fairy ring. These rings expand outward, their underground mycelial network pushing steadily, sometimes growing several meters across in a single decade. This slow, persistent expansion showcases the mushroom's role as an engineer of nutrients. Ancient folklore once whispered of tiny dancing creatures, creating these perfect arcs, leaving enchanted trails on the land. Today, researchers ponder if this growth reflects fungal cooperation or a silent competition for resources beneath the soil. Picture the dappled leaf shade, feel the slow rain, and let this quiet, circular persistence speak of the earth's thoughts, line by line. You might recall the subtle pulse of life beneath the soil, a constant, unseen growth. This quiet energy extends to human hands as you learn the deliberate art of mushroom cultivation. From simple logs to sterile laboratory environments, people transform humble substrates into a rich harvest. It is a patient dialogue, guiding nature's own processes. Consider yourself an engineer of nutrients, carefully providing signals for growth and shelter for the fruiting bodies. Centuries ago, folklore named these traces fairy handiwork. Artisans turned their scents and colors into quiet rites. Even today, researchers debate: does cooperation or subtle competition best explain mycelial patterns in cultivation plots? You watch the slow thought of the forest, borrowed and made visible, line by patient line. Let this exchange linger, picturing leaf shade and slow rain before the next quiet turn. You consider how the forest floor, a quiet library of life, has always offered its subtle gifts. Across continents, the knowledge of which mushrooms to gather and which to avoid forms an intricate tapestry, woven through generations. This wisdom ensures the safe transfer of nutrients and flavors, from the wild to your plate. Ancient traditions teach simple measures: how many hours a mushroom takes to fruit, the grams of spores it releases, or tracing meters of mycelium in a handful of soil. These are the threads of wisdom passed down, once named fairy handiwork in old folklore, where artisans turned forest scents and colors into daily rites. Today, researchers still quietly debate whether cooperation or competition best explains the patterns recorded in their field plots. A gentle echo of the forest, thinking slowly in the dark, line by line. You might picture leaf shade and slow rain, a quiet exchange. Let this enduring connection to the earth linger, a soft pulse beneath your thoughts. You might not see it, but beneath the damp leaf litter, a silent, intricate architecture persists, unseen. These are the fungal hyphae, minute cellular threads forming a vast underground web known as mycelium. A single handful of forest soil can contain many miles of these delicate filaments, constantly seeking and redistributing life's essential elements. Think of them as the forest's quiet engineers, slowly dissolving decaying matter and recycling nutrients back into the ecosystem, a process invisible to the naked eye. This intricate web, often just micrometers wide, serves as a vital communication highway, sharing resources and sending signals between plants and other organisms. Folklore once whispered of fairy handiwork, explaining the sudden bloom of mushrooms from seemingly barren ground, unaware of the patient, hidden labor woven beneath. Scientists still debate the precise balance of alliances and rivalries within these subterranean networks, a complex dance of survival and symbiosis. You feel the quiet hum of this microscopic world, a persistent and elegant force, shaping the very ground you walk upon. You sense a quiet, persistent energy shaping the very ground beneath your feet. Fungi employ remarkable enzymes, like lacase and peroxidase, to perform intricate chemical work. These proteins act as nature's tireless engineers, dismantling tough plant matter into simpler, usable forms. This process releases vital nutrients, enriching the soil for countless other organisms. Consider the unseen labor. Meters of mycelium in a handful of soil slowly turn decay into fresh possibility. Lacase, for example, extends its power beyond the forest. It finds roles in sustainable textile dyeing and paper manufacturing. Researchers still debate the full spectrum of these enzymes' capabilities, constantly uncovering new applications. This quiet alchemy unfolds everywhere, a continuous, elegant persistence, moment by moment. Consider the silent architects working beneath the forest floor, their intricate designs now emerging into your daily world. These fungal threads, woven into dense mats, offer an alternative to traditional plastics for protective packaging. Imagine a custom-grown cushion, perfectly molded to safeguard delicate items. This isn't a distant dream. Companies now cultivate mycelium into forms like shock-absorbing inserts or insulation panels. You might hold a parcel cushioned by these natural fibers, a silent testament to fungal engineering. It feels as though the forest itself lends its quiet strength, weaving protection with unseen hands. Folklore once named these traces fairy handiwork. This gentle persistence whispers of a future where practical needs meet the elegant solutions found in nature's deep, dark patience. Beneath the quiet forest floor, an ancient partnership continues its delicate work. Consider the orchid seed, tiny as dust, unable to sprout without its specific fungal companion, or the young pine seedling, extending its roots into a vast network of mycelial threads, drawing sustenance from an unseen fungal web. These fungi act as patient engineers, exchanging vital nutrients and water for sugars produced by the plants. Researchers still ponder whether these intricate exchanges are purely cooperative, or if subtle competition shapes their enduring patterns. It feels as though the forest borrows threads of this dark, slow thought, line by line, a notion folklore once named fairy handiwork. This unseen effort, measured in meters of mycelium spanning a handful of soil, stands as a silent testament to life's persistent ingenuity. Picture the dappled leaf shade and feel the slow rain. Let this quiet exchange linger in your thoughts. You sense a quiet language unfolding beneath your feet, carried not by sound, but by unseen organic threads. In just a handful of soil, miles of fungal mycelium weave a living network, exchanging vital nutrients and signals. This underground system, sometimes called the wood wide web, allows fungi to engineer the flow of sugars from trees and vice versa. Yet, the precise balance between selfless cooperation and strategic competition within this vast exchange remains a subject of ongoing scientific debate. Some patterns suggest a mutual benefit, a vast cooperative. Others hint at a silent negotiation for survival, a careful allocation of resources. You picture the forest floor thinking slowly in the dark, its intricate messages echoing through unseen pathways. This elegant persistence quietly shapes the world above. You have sensed the quiet influence of fungi before, their unseen presence shaping the world. Now, consider their vital role when forests face the harsh grip of drought, acting as silent protectors. These mycorrhizal networks extend tree root systems, reaching into deeper soil layers for precious water. Imagine a vast, underground plumbing system, meticulously laid by fungal threads, delivering moisture to thirsty trees. This hidden partnership can significantly enhance a forest's ability to withstand prolonged dry spells. It is a testament to nature's ingenious solutions, working far beneath the surface. This unseen collaboration guards the very breath of the forest, a quiet miracle unfolding in the dark. The forest floor, seemingly still, pulses with an intricate hidden life. Mycelial threads, the vegetative body of fungi, can stretch for many miles beneath the soil, forming an expansive, living web. This network acts like a vast, subterranean brain for the ecosystem. During periods of low rainfall, these delicate networks transport water and critical nutrients to stressed trees, becoming essential conduits of survival. Scientists observe how fungi can even break down complex organic matter, releasing nutrients otherwise locked away. The exact mechanisms of water transfer, however, remain a subject of ongoing scientific inquiry. A continuous, quiet exchange unfolds, sustaining life where a tree's own roots might falter. You might wonder how trees seem to anticipate the parching Sunday fungi to facilitate a complex chemical signaling system between trees, allowing them to share warnings and resources. Think of it as an ancient, organic internet, connecting distant points. When one tree experiences water stress, its fungal partners can alert neighboring trees, potentially prompting them to conserve moisture or increase their own water uptake. This silent language, a form of biological communication, perhaps inspired ancient folklore about talking forests and sentient groves. It speaks of a wisdom deeper than human understanding, a whispered strategy against the harshest summer, orchestrated by unseen threads. The scale of this subterranean effort often escapes direct observation. A single handful of forest soil can contain several kilometers of mycelial threads, a staggering density of life. This intricate web performs its vital tasks tirelessly, largely unseen. Such hidden diligence, working beneath the Earth's surface, once gave rise to stories of forest spirits, of tiny, unseen hands weaving protection for the trees. Artisans, in turn, learned to interpret the forest's subtle scents and colors, turning them into rites of seasonal celebration. It is a quiet, persistent hum of life, a subtle tapestry woven in the dark, beneath your very feet. Holding the forest together, the forest breathes a slow, deep rhythm, guided by unseen currents. Even within these partnerships, nature often holds layers of complexity. Researchers still actively debate whether fungal interactions are purely cooperative or also involve elements of subtle competition. This dynamic interplay shapes the entire ecosystem, yet the overall outcome frequently benefits the entire forest, creating robust conditions for diverse life to flourish. This resilience ensures the continued growth of trees, providing shelter for creatures and the unique, earthy flavors found in edible mushrooms after a restorative rain. You might taste this ancient bargain in the very soil. a delicate balance, continuously shaping the very essence of the forest's enduring bounty. You might walk past them daily, tiny kingdoms thriving beneath your notice. Urban fungi transform city spaces. They appear from the soil of park trees to the smallest sidewalk crack, playing vital ecological roles. These resilient organisms break down organic matter, recycling nutrients to sustain city greenery. A handful of urban soil can hold meters of fungal threads, silently weaving life into the asphalt jungle. Researchers often debate whether cooperation or competition best explains these urban networks. They adapt rapidly to fragmented habitats. They are the unseen architects, engineering resilience in unexpected corners. Consider the quiet persistence of these miniature worlds, working tirelessly as the city sleeps. Just as mycelial networks weave unseen beneath the soil, their culinary impact often takes on a quiet, foundational presence. Dried mushroom powders, for instance, transform subtle forest flavors into a potent, shelf-stable concentrate. A small spoonful can carry the depth of several fresh caps, a whisper of umami waiting to unfold. This ancient preservation method, once a practical necessity, now serves as a chef's secret, a dust of woodland magic. Imagine the earthy aroma released as fine particles dissolve into a simmering broth. Its character deepens with a slow, dark richness. It's a testament to the mushroom's role as an engineer of flavor. Its unique compounds concentrate into a form that endures, much like the quiet persistence of underground networks. You taste not just a seasoning, but a distillation of time, a patient echo from the forest floor. Let that concentrated essence settle, a gentle reminder of hidden depths. You recall the quiet hum of the forest floor, a silent network of life unfolding. For millennia, specific mushrooms have been quietly harvested for their profound medicinal properties. Consider shiitake, reishi, and turkey tail. These are nature's subtle engineers. They craft complex compounds, interacting with human systems in gentle ways. Ancient traditions, especially in Asia, revered reishi as the mushroom of immortality. Its potential to restore balance was deeply valued through history. Modern research now delves into their intricate polysaccharides and triterpenes. Scientists debate the precise mechanisms, exploring how they might support immune function. You might encounter them as extracts, teas, or simply dried slices. Their earthy aroma hints at centuries of accumulated wisdom. This persistent presence in human health continues to unfold, a gentle whisper from the forest. You might trace the quiet journey of a prized truffle, from its hidden forest origins to a global auction. A single white truffle, unearthed by a trained dog in an Italian forest, can rival precious gems in value. Imagine a few hundred grams fetching thousands of dollars. This reflects its ephemeral nature and intense earthy aroma. The underground treasure, a marvel of the fungal kingdom, fuels an ancient, almost ritualistic hunt. This tradition passes down through generations. Its complex perfume, a symphony of notes, transforms simple dishes into culinary experiences worldwide. Scientists still debate the precise symbiotic relationships needed for its elusive growth. It is a delicate dance of roots and mycelium, resisting easy cultivation. You consider how these humble fungi, rooted in ancient soil, quietly weave themselves into human commerce. They form a persistent, elegant thread in our global culture. Just as the forest holds countless secrets, so too does each mushroom reveal its own quiet identity. Beneath its cap, a profound clue often waits. A spore print, formed by billions of microscopic cells, reveals a distinct color from pure white to deep rust, purple, or jet black. This unique pigment serves as a primary identifier, guiding those who seek to understand the fungal world. Imagine these delicate dustings as the forest's own fingerprint, a silent declaration of lineage. Folklore once called these ephemeral traces fairy handiwork, envisioning hidden rituals marked by vivid hues. Artisans, too, sometimes transformed these natural pigments into dyes or ceremonial rites. Each color offers a quiet narrative, a code for the patient observer. Consider the hidden architecture beneath a mushroom's cap. These varied surfaces, gills, pores, or tooth-like projections form the hymenophore, a dedicated spore-producing engine. A single mature mushroom can release billions of microscopic spores carried on air currents like dust motes. Each design, whether radiating gills or a spongy matrix of pores, optimizes the surface area for spore production. This elegant biological engineering ensures the next generation finds purchase, linking the forest floor's nutrient cycles. Folklore once whispered of fairy staircases hidden beneath toadstools, perhaps inspired by the delicate, labyrinthine patterns. You can almost hear the silent, patient work of these structures, unfolding their designs in the quiet dark. You notice how the fungal world often presents itself in two distinct, persistent ways. These are the Basidiomycetes and Ascomycetes, shaping daily life in quiet, practical forms. You might consider Basidiomycetes as architects of many visible forest forms. Ascomycetes, however, often work more subtly below ground. Basidiomycetes often gift us the classic mushroom cap, emerging in mere hours. Ascomycetes might spend weeks crafting a truffle's hidden flavor. Their mycelial networks, stretching meters through a handful of soil, act as silent engineers, exchanging nutrients and signals. This quiet persistence, once folklore's fairy handiwork, now sparks scientific debate. Researchers still question if cooperation or competition best explains these intricate, dark patterns. You feel their presence in the quiet forest, a slow, dark thought beneath leaf shade and rain. Let this unseen exchange linger, a gentle rhythm in the earth's deep slumber. You observe how fungal colors touch daily life, often in quiet, practical ways. Many fungi produce vibrant pigments, not just for display, but as essential shields against the sun's harsh ultraviolet radiation. Think of these compounds as a natural, living sunscreen, protecting delicate fungal structures. Ancient artisans recognized this potent chemistry, extracting rich purples and yellows from certain mushrooms to color textiles and adornments. Folklore once named these traces fairy handiwork, transforming earthly hues into rites of beauty. Researchers still debate their full purpose. Do these same pigments also play a role in signaling or competition within the forest's intricate web? Their silent, persistent chemistry continues to unfold. Line by line, you might sense the forest floor breathing, a subtle pulse beneath the fallen leaves, a quiet continuation of life's grand exchange. Within this unseen realm, fungi never work in isolation. They form complex microbiomes, sharing their intricate networks with countless bacteria and even elusive viruses. These microscopic engineers orchestrate the very foundations of nutrient cycling, sending signals through the soil like whispers. Consider the sheer scale. A mere handful of forest soil can contain meters of mycelial threads, each strand a conduit for a hidden economy. This ancient partnership not only builds shelter for tiny creatures, but also subtly influences the distinct flavors found in our foods. Researchers still ponder whether cooperation or competition is the dominant force in these persistent, elegant patterns. Folklore once attributed such unseen workings to fairy handiwork, a testament to their mysterious influence. This quiet, practical persistence, like slow rain on leaves, allows the delicate exchange to linger, preparing the way for the next turn. You might sense the quiet shift when a forest begins to change, a subtle alteration in its ancient rhythm. Certain invasive fungi, unseen for years, weave through root systems like a slow current, altering the fate of towering trees. Scientists observe how these silent invaders challenge the very structure of ancient forests, sometimes leading to widespread decline. Mycelial networks, often meters long in a handful of soil, act as unseen engineers of decay, redirecting vital resources. Researchers still debate whether these patterns reflect inevitable competition or a complex, misunderstood cooperation. You simply witness the slow, patient work of adaptation, unfolding leaf by fallen leaf as the forest breathes its quiet changes. You might notice the quiet persistence of fungi, even when conditions turn harsh. When the forest floor dries to a whisper, mushrooms employ deep strategies for survival. One key defense involves melanin, the same dark pigment in your skin. This natural shield protects fungal cells from intense UV radiation and desiccation. Some species also form dense mycelial sheaths, like woven cloaks around their delicate hyphae. These sheaths trap precious moisture, creating a vital microclimate deep within the soil. It is as if the forest itself borrows threads to think slowly in the dark, preserving its wisdom. Researchers still debate whether cooperation or competition best explains these patterns of endurance. This silent engineering ensures the continued flow of nutrients and signals, even when all seems dormant. Exhale, picture leaf shade and slow rain. Let the exchange linger before the next quiet turn. The quiet persistence of life extends beyond what you see, reaching into the very atmosphere. Fungi release tiny particles that act as ice nuclei, initiating the formation of snowflakes and raindrops. This fungal ice nucleation allows water to freeze at surprisingly warmer temperatures. Imagine these spores as miniature engineers, shaping weather patterns from the ground up. Researchers still debate the exact impact, weighing fungal contributions against other atmospheric particles. This mirrors the forest borrowing threads, slowly thinking in the dark, influencing the world line by line. You feel the subtle hand of the mycelial network, quietly persistent, linking earth to sky. You might imagine life retreating from perpetual night, yet deep within the earth, a different kind of forest whispers. Cave and karst fungi thrive in absolute darkness, engineering vital nutrient cycles where no sunlight ever reaches. Their mycelial networks can stretch for meters beneath the surface, silently processing minerals and organic matter. Consider these fungi as unseen architects, crafting the very foundations for other cave life. Researchers often debate whether these subterranean threads primarily cooperate or compete for scarce resources. This tension mirrors the delicate balance found within the deep, isolated cave environments. Ancient folklore sometimes attributed strange cave growths to fairy handiwork, sensing a silent, persistent presence. You can almost feel the damp, earthy scent of their hidden labor, a slow, deliberate breath in the quiet dark. This enduring presence reminds you how life finds a way, even where light has long forgotten to touch. You might consider how life adapts to its surroundings, much like the unique stories told by isolated island ecosystems. On remote islands, fungi often evolve in splendid isolation, leading to many species found nowhere else on Earth. Imagine these unseen architects quietly shaping their confined worlds. Some island fungi, perhaps resembling delicate coral or tiny luminous bells, become crucial engineers of nutrient cycles. They break down fallen leaves and ancient wood, returning vital elements to the soil. A process happening meter by meter beneath your feet. Researchers actively debate the precise mechanisms driving this intense island endemism. They consider whether chance, colonization, or specific competitive pressures best shape these unique fungal lineages. Their quiet persistence, often hidden beneath the soil, forms an essential, elegantly persistent thread in the island's delicate fabric. This allows the forest to slowly think in the dark. You might not imagine fungi thriving where land meets the sea, a place of constant flux and salinity. Yet, a specialized community of mushrooms and molds anchors itself to mangrove roots and submerged wood, patiently breaking down tough organic matter. These coastal decomposers are masters of resilience, processing the salty, oxygen-poor debris that few other organisms can manage. Scientists often debate whether their intricate networks represent pure competition for scarce resources or a silent, cooperative effort, knitting together the fragile ecosystem. It feels as though the forest itself borrowed threads to think slowly in the dark, line by line. Their quiet work ensures the continuous flow of life, a persistent hum beneath the shifting tides. As you drift through the Earth's hidden architectures, you sense the subtle hum of ancient partnerships, particularly beneath Africa's sun-drenched savannas. Here, tiny architects cultivate their own food, a sophisticated agriculture built entirely around specific fungi. Termites do not eat wood directly. Instead, they gather plant matter, chew it, and feed it to a mushroom garden deep within their mounds. These fungi break down cellulose, transforming it into a digestible food source for the termites. This elegant process has been refined over millions of years. The symbiotic dance, where termites provide the substrate and the fungi offer nutrition, remains a marvel of natural engineering. Researchers still unravel the precise chemical signals governing this intricate exchange. They debate whether cooperation or competition best explains these subterranean farms. Ancient folklore, long before microscopes, simply named such perfect growth fairy handiwork. It attributed the mysterious bounty to unseen hands beneath the leaf shade. You feel the slow rhythm of this quiet, persistent cycle, a reminder of how life finds its way through elegant, fungal solutions. You have seen how threads of life weave unseen beneath the forest floor, a quiet network of exchange. Now, consider a different kind of hidden architecture, built by creatures you might not expect. In tropical rainforests, tiny leafcutter ants maintain elaborate underground farms, cultivating specific fungi as their sole food source. These fungal gardens can span several cubic meters, feeding millions of ants within a single colony. You might imagine this as a miniature agricultural marvel, where ants meticulously prune leaves, carry them to subterranean chambers, and plant them for their fungal crops. Researchers still debate the precise balance of cooperation and subtle competition within this ancient partnership. They observe how the fungal species itself has evolved to become entirely dependent on the ants for propagation, a living tapestry. It feels as though the forest borrowed these threads to think slowly in the dark, line by line. Exhale, picturing the quiet industry beneath the leaf shade and the slow, persistent rain. Let this intricate exchange linger before the next quiet turn. As threads of mycelium weave through the soil, you might consider how other hidden patterns emerge, quietly touching human lives. Across ancient cultures, certain mushrooms offered more than sustenance. They provided vibrant pigments, transforming fabrics and art. Imagine the rich purples from Time's Cortinarius, Time's Species, or the deep rusts from Time's Phaeolus schweinetzii asterisk, prized by textile artisans. These fungal dyes often proved more lightfast than many plant-based alternatives, holding secrets within their cellular structures. It was a silent spectrum, borrowed from the forest floor itself. Folklore whispered of fungi as nature's own paint pots, their hues reflecting the quiet magic of the woods. Researchers still unravel the complex enzymatic processes that create these fungal colors, revealing a palette more intricate than first understood. You might now see a forest walk not just in greens and browns, but in the potential for crimson, gold, and indigo, waiting beneath your steps. You have journeyed through the fungal world's visible wonders, from towering brackets to glowing caps. You marvel at their tangible forms. Yet, a pervasive aspect often remains unseen. It is a silent, swirling presence in the very air you breathe. Each breath draws in countless fungal spores. These tiny architects of decay and renewal carry subtle signals. For some, these signals trigger allergic responses. Imagine them as microscopic seeds. Thousands may drift within a single cubic meter of air. They settle silently through your home, your garden, and wild spaces beyond. This constant, invisible rain can manifest as seasonal sniffles. It may cause persistent irritation. Such moments offer a quiet reminder of life's intricate, unseen connections. It is as though the forest itself breathes out these invisible threads. They weave an unseen tapestry around you. Researchers continue to unravel specific proteins within these spores. This remains a complex puzzle of biological recognition. You learn to recognize these subtle shifts. A gentle nudge from the hidden world invites a moment of quiet awareness. As the quiet forest exhales, you sense the intricate exchanges continuing beneath the canopy. Among these hidden interactions, certain beetles and slugs play an unexpected role in many mushroom life cycles. They become unwitting couriers, carrying microscopic spores across the forest floor. Imagine a tiny living vehicle, moving slowly through the undergrowth, its body dusted with countless potential new fungal colonies. Researchers still ponder if this partnership evolved through mutual benefit or opportunistic feeding. Some fungi even release specific scents to attract these small creatures, ensuring their genetic legacy travels. This quiet, persistent journey of spores, borne by creatures often overlooked, elegantly ensures the mushroom's subtle presence endures. You might observe how a sudden storm can transform the forest floor, unveiling new life within hours. After heavy rains, certain mushrooms fruit with astonishing speed, their delicate forms emerging from hidden mycelial networks that can stretch for meters beneath a single handful of soil. These ephemeral engineers quietly orchestrate nutrient cycles, releasing signals and flavors, even providing shelter on a miniature scale. Folklore once whispered of these fleeting appearances as fairy handiwork, while artisans drew inspiration from their fleeting scents and colors for ancient rites. Today, researchers still debate whether cooperation or competition best explains the intricate patterns observed in these post-storm fruiting events. Picture the quiet exchange beneath leaf shade and slow rain. Let this mystery linger softly. You often find traces of the forest's quiet work woven into human stories. Across cultures, the mushroom's sudden appearance and mysterious growth inspired tales of hidden realms and ancient wisdom. These narratives often echo the fleeting hours it takes for a cap to unfurl or the silent spread of mycelial networks beneath the soil. Folklore once named these ephemeral traces fairy handiwork, a whisper of magic in the mundane. Artisans, too, turned their earthy scents and subtle colors into ancient rites and symbols. It feels as though the forest itself borrowed threads to think slowly in the dark, weaving its silent presence into human consciousness. You sense this quiet, practical persistence, an elegant thread connecting deep earth to daily life. Let this exchange linger before the next quiet turn. You recall the vast, unseen networks beneath the earth, always at work. Now, through citizen science, thousands worldwide help map these elusive fungal territories. Their collective effort much like mycelial threads, weaves countless individual observations into a grander understanding. Simple measures become vital data: the hours to fruit, grams of spores, or meters of mycelium in a handful of soil. This diligent tracking helps researchers decipher fungal growth patterns, revealing how these organisms silently engineer our planet's ecosystems. It feels as though the forest borrows threads to think slowly in the dark, line by line. Folklore once named these intricate traces fairy handiwork. Researchers still debate if cooperation or competition best explains patterns recorded in field plots. Let this patient, collective gaze deepen your appreciation for the hidden life that thrives. Picture leaf shade and slow rain, letting the quiet exchange of knowledge linger before the next gentle turn. You might not see the silent threads connecting every living thing, yet within each mushroom, a unique genetic code acts as a precise identifier. Scientists use a specific DNA region, the internal transcribed spacer, or ITS, as a global barcode for fungal species. This tiny segment, often a few hundred base pairs long, allows researchers to identify mushrooms with remarkable accuracy, even from a microscopic spore or a fragment of mycelium. It is like a universal tag, revealing which species are engineering nutrients, sending signals, or forming shelter in human-scaled ways. This molecular fingerprinting clarifies debates about cooperation versus competition within fungal communities, showing how the forest might borrow threads to think slowly in the dark. Such quiet, persistent work elegantly maps the unseen world, drawing detailed lines across the planet. You might notice how certain moments in the forest feel ripe with anticipation. After a deep rain, or when the moon's light waxes full, some mushrooms emerge with striking synchronicity. Their mycelial networks, often spanning meters beneath the soil, sense these shifts, signaling the perfect hour to fruit. This precise timing once inspired tales of fairy rings and hidden magic, as if unseen hands orchestrated their sudden appearance. For centuries, people believed these ephemeral growths were the handiwork of unseen forest beings, appearing and vanishing by unseen command. Even now, you might feel a shiver of that ancient wonder. The forest seems to breathe slowly, revealing its secrets line by quiet line. You might not always perceive the quiet architects guiding the forest's grand design. Yet, fungi orchestrate the slow, persistent dance of forest succession, a process unfolding across generations. Consider how a single fallen tree becomes a stage for countless fungal species, each playing a vital role in its return to the earth. These unseen networks, often meters of mycelium woven through a handful of soil, act as silent engineers. They recycle nutrients, signal changes, and shape the ground beneath your feet in human-scaled ways. Researchers still debate whether cooperation or competition best explains patterns recorded in field plots. This remains a quiet tension in the forest's ongoing story. Ancient folklore once named these traces fairy handiwork. Artisans turned their subtle scents and colors into meaningful rites. You exhale, picturing leaf shade and slow rain. Let the profound exchange linger before the next quiet turn. You recall the quiet persistence of life just beneath the surface. A subtle hum, often unheard. You discover how many mushrooms, through their expansive mycelial networks, become silent architects of soil carbon storage. These intricate fungal threads actively sequester carbon. They lock it away for centuries, much like a meticulous archivist preserving ancient scrolls. Consider a single handful of forest soil. It might hold miles of these delicate threads, each a tiny, living conduit for nutrient exchange. These threads also serve as vital vessels for stored atmospheric carbon. researchers still debate the precise balance of cooperation versus competition in these underground patterns. They wonder if the forest truly thinks slowly, line by line, through its fungal partners. You begin to sense the profound, elegant persistence of this quiet exchange, a vital, enduring rhythm unfolding beneath your very steps. You might recall the quiet persistence of unseen networks. Yet, some fungi thrive only in the stark aftermath of a blaze. When wildfire sweeps through a forest, the ash-rich soil becomes a sudden fertile stage. Specific mushrooms fruit there, sometimes within days or weeks. These pyrophilous species emerge with surprising speed. Their spores often lie dormant for decades, patiently awaiting the intense heat. Scientists observe these early pioneers, like the charcoal-loving thymes, Pholiota carbonaria asterisk. They act as vital engineers, initiating nutrient cycling in the scorched earth. Yet, the precise triggers for their sudden appearance remain a subject of quiet debate among mycologists. Is it the removal of competitors, a sudden influx of ash-borne nutrients, or a complex chemical signal from the fire itself that awakens their slumber? You might imagine the forest floor, once a dense tapestry, now borrowing these fungal threads to slowly begin its patient, dark thought anew. Their silent emergence offers a profound testament to nature's enduring capacity for renewal, even after deep disruption. Picture the faint steam rising from damp ash. These resilient forms begin their quiet, essential work. You sense the forest's quiet breathing, a slow, dark thought woven line by line into the very fabric of leaves and stems. Deep within these living tissues, a hidden fungal world thrives. Endophytes, these microscopic mushrooms, reside silently inside plants without causing disease. They act as unseen engineers, subtly shaping a plant's life. Consider their influence on nutrient uptake, internal signaling, and even the unique flavors of fruits and herbs you taste. Researchers still debate whether cooperation or competition best explains their patterns. Are these endophytes benevolent partners, offering mutual benefits like enhanced growth or pest resistance, or do they sometimes subtly contend for resources within the plant? A delicate balance often exists, poised between harmony and rivalry. Imagine meters of mycelial threads, like those beneath your forest floor, now miniaturized within a single stem. This elegant persistence touches daily life, often unnoticed, yet profoundly practical. You might picture leaf shade and slow rain, letting this quiet exchange linger. The fungal kingdom's hidden dance continues, an enduring mystery within every green thing. You might encounter old tales guiding foragers, offering simple clues for mushroom safety. For centuries, many believed a mushroom was safe to eat if its cap peeled easily, a comforting trick passed down through generations. Yet, modern mycologists confirm this peeling test holds no reliable correlation with edibility. This folklore offered a dangerous shortcut, a deceptive whisper in the woods. The deadly death cap, Amanita phalloides asterisk, for instance, often peels quite readily, directly contradicting the old wisdom. Scientists now emphasize precise identification through spore prints, microscopic features, and chemical analysis, moving beyond such perilous superstitions. Verified knowledge serves as your truest guide in the silent, dappled light. Let this gentle caution settle. Considering the forest's quiet lessons, you feel the quiet, persistent touch of fungal domestication in your daily life. Globally, millions of tons of cultivated mushrooms nourish communities, a testament to their efficient growth as nutrient engineers. Consider the vast, unseen mycelial networks weaving flavor and sustenance into our food systems. These intricate threads, stretching meters in a small handful of substrate, transform simple organic matter into complex nutrients. Scientists still debate if their cultivated success arises from inherent cooperative strategies or a quiet competitive edge over other microorganisms. This ancient alchemy ensures vital nourishment. Let this hidden exchange linger, a quiet hum beneath the surface of your world. You might sense the quiet work of unseen networks beneath your feet, constantly reshaping the world. These fungal threads, known as mycelium, are now harnessed to create sustainable materials, offering a biodegradable alternative to plastics. Imagine packaging that simply returns to the earth after its purpose. This living material grows into specific shapes, binding agricultural waste into durable, lightweight composites. Scientists explore its potential for insulation, furniture, and even building blocks. It is a quiet revolution, where the forest's ancient engineers offer solutions for modern challenges. Researchers still debate how best to optimize these growth patterns, balancing speed with strength. You can almost feel the slow, patient growth, weaving a new future from Earth's own silent loom. You have observed how fungal networks quietly sustain life across Earth's varied landscapes. This elegant persistence extends even to the void, where scientists explore fungi for future space missions. Imagine a compact fungal farm designed to provide food and recycle waste for astronauts on distant outposts. Researchers investigate species like oyster mushrooms, *Pleurotus austriatus *, for their remarkable ability to grow on mission byproducts. They transform discarded materials into edible biomass, a vital bioregenerative process. This could significantly reduce the need for constant resupply from Earth, addressing a critical logistical challenge. The scientific debate often centers on optimizing growth conditions in microgravity and radiation, carefully balancing efficiency with resource conservation. These fungi emerge as living engineers, subtly transforming the discarded into sustenance. A quiet alchemy for the stars. You might picture mycelial threads weaving through a lunar habitat, a gentle promise of self-sufficiency blossoming far from home. A forest floor, a tapestry of decay and rebirth, often holds its most resilient secrets. You might consider a mushroom cap's ephemeral nature, yet its microscopic spores possess an extraordinary toughness. They survive conditions that would obliterate most other life forms. These tiny propagules can endure the vacuum of space. They resist intense radiation and withstand temperatures far below freezing. Their robust design is truly remarkable. Researchers continue unraveling the precise molecular mechanisms behind this resilience. They debate whether specific proteins, unique cell wall compositions, or metabolic dormancy offers the primary defense. It feels like a biological time capsule, patiently waiting to awaken. It carries the blueprint of its fungal parent across vast distances, navigating through harsh epochs. This capacity for survival challenges our understanding of life's very boundaries. Imagine these minute entities, silently drifting. They hold the potential for new life against incredible odds, a testament to nature's quiet, persistent engineering. You might recall the deep, savory notes found in many East Asian broths. This richness often comes from the shiitake mushroom. It has been cultivated for over 1,000 years in regions now known as Japan and China. Its distinct, earthy aroma deepens any dish. Ancient texts describe its careful propagation on fallen logs, a practice shaping culinary traditions for centuries. The discovery of its unique flavor profile, rich in guanylate, transformed simple meals. This compound, when combined with glutamates, amplifies the sensation of umami. Researchers still explore how these precise flavor compounds interact on a molecular level. Imagine the subtle shift in taste, a quiet secret passed down through generations of cooks, Let that lingering warmth settle gently. You feel the quiet hum of the forest floor, a subtle negotiation. This ancient rhythm has shaped human interaction for centuries. Across European landscapes, traditions guide how you might gather wild mushrooms. These practices are often codified into modern foraging laws. Such regulations reflect a deep understanding of fungi as silent engineers. They create nutrients and flavor from the soil, touching daily life. These measures consider a delicate balance. Success is not just grams of spores, but meters of mycelium left undisturbed. Folklore once named fruiting bodies fairy handiwork, a magic to be respected. This respect influences current ethical guidelines. Researchers still debate if cooperation or competition best explains patterns in field plots. This tension informs the spirit of sustainable harvest. You exhale, picturing leaf shade and slow rain. Let the forest's quiet wisdom settle before the next turn. You sense the forest breathing, a quiet, ancient rhythm beneath the canopy. Indigenous knowledge reveals how forest fungi touch daily life, practical and persistent. You learn to read the subtle signs. Hours until a certain fruiting body matures. You estimate the grams of spores a single cap might release. This wisdom sees fungi as engineers of nutrients, signals, flavor, and shelter. In ways you can grasp, you observe how artisans once turned their vibrant colors into rites, echoing the forest's deep, slow thoughts. Researchers still debate if cooperation or competition best explains these intricate subterranean patterns. Picture the gentle leaf shade and slow rain, letting this deep, quiet exchange linger. You carry the quiet understanding of the forest's subtle rhythms. Foraging safety protocols begin with careful observation of a mushroom's life cycle. Some varieties can fruit in just hours. Others take weeks to fully mature, a vital distinction for accurate identification. This patient attention, like the forest borrowing threads to think slowly, reveals fungi as quiet engineers of the ecosystem. A single handful of soil might hold meters of mycelial threads, constantly signaling and exchanging nutrients. Folklore once named these unseen traces fairy handiwork, honoring their mysterious, persistent presence beneath the earth. Modern researchers still debate whether cooperation or competition best explains patterns within these vast underground networks. Allow this intricate dance of growth and decay to settle gently in your mind. A quiet, practical wisdom. Beyond the silent spread of mycelium, you find fungi communicating through the air, with whispers carried on the breeze. Certain species, like the stinkhorn, emit potent compounds mimicking decaying flesh. This fly-carrion odor acts as an irresistible lure for insects, drawing them into the fungus's world. It's a bizarre olfactory illusion, transforming forest air into a deceptive, pungent banquet. Flies, seeking a meal or a place to lay eggs, become unwitting spore couriers. Scientists still debate if this exchange represents true pollination, a mutual dance, or is it merely clever fungal exploitation for dispersal? This intricate, sometimes unsettling strategy ensures the mushroom's lineage continues. Such hidden signals reveal the forest's deep, persistent ingenuity. They move life stories across the landscape, one fleeting odor at a time. You may have felt the quiet hum of life beneath the soil, a sensation often traced to unseen networks. These fungal threads act as living sensors, constantly sampling their environment for nutrients and signals. A single handful of forest soil, for instance, can contain several kilometers of these delicate, branching networks. Researchers still debate whether cooperation or competition best explains the intricate patterns recorded in field plots. This silent, subterranean communication allows the forest to think, slowly in the dark, line by line, adapting to changes unseen. As you exhale, picture leaf shade and slow rain, letting the intricate exchange beneath the surface linger before the next quiet turn. You might sense the quiet work happening below, a hidden architecture supporting life. Mycorrhizal fungi form essential partnerships with nearly all tree seedlings, sharing vital resources. A single gram of forest soil can hold kilometers of these delicate fungal threads, extending the reach of young roots far beyond their own capacity. This ancient alliance allows trees to access water and nutrients they might otherwise miss. Yet, scientists continue to explore the nuanced dynamics, debating whether these networks are purely cooperative or if subtle competition also shapes their intricate design. It's a silent negotiation, etched into the very fabric of the soil. Imagine the quiet growth, the unseen exchange beneath the earth, a foundational hum for future forests. You observe the forest's quiet calendar, a rhythm etched deep into the soil. Each season brings forth its own unique fungal characters, a silent procession through the year. Consider the first blush of spring. When morel mushrooms emerge, their honeycomb caps a fleeting treasure beneath warming leaves. They act as nature's subtle engineers, recycling nutrients and shaping the forest floor in their brief, vital appearance. You might measure their swift growth in mere hours, a testament to their ephemeral purpose. Folklore once whispered of their sudden arrival as fairy handiwork, a clandestine gift left by unseen hands in the damp earth. This delicate timing, from the tender morels of spring to the robust porcini of autumn, illustrates a complex interplay. Scientists still ponder whether this seasonal dance is primarily driven by ancient cooperation or silent competition among countless species. You feel the cool air, a slow breath of rain, as these exchanges quietly unfold. You continue to notice the subtle artistry woven into the forest floor, a silent tapestry of life. This quiet beauty often invites closer inspection through a camera's lens. Capturing the true spirit of mushrooms, our main subject, requires mastering light's dance and the delicate release of their spores. A photographer might wait for perfect diffused light, highlighting a velvety cap or intricate gill structure. This reveals textures often invisible to a casual glance. The simple act of making a spore print transforms a mushroom into a living canvas. Its microscopic reproductive cells fall in radial patterns, like a cosmic clock marking silent time. These ethereal dustings, once named fairy handiwork in folklore, are now crucial for scientific identification. They form a quiet language of the forest floor. Each carefully composed image offers a glimpse into a world both fleeting and profound, a testament to nature's elegant persistence. Building on the silent work you've observed, consider how these quiet engineers interact with the very air we breathe. You might not always see the direct influence, yet fungi play a profound role in Earth's atmospheric balance. Mycelial networks, stretching for miles beneath your feet, actively sequester carbon from the soil, locking it away from the atmosphere. A single hectare of forest soil can hold tons of carbon within its fungal biomass. Researchers are still quantifying the exact magnitude of this carbon sink, debating whether mycorrhizal fungi or saprophytic species contribute more significantly. It is like an unseen underground library, constantly cataloging and storing Earth's ancient breath. This hidden process subtly shapes the climate, a slow, persistent hum beneath the forest floor. Imagine the forest breathing, a vast exchange of gases where fungi act as crucial regulators. Certain fungi release volatile organic compounds, or VOCs, into the air, influencing cloud formation and precipitation patterns. These microscopic exhalations can travel for hundreds of miles. You might catch a hint of their earthy perfume after a rain, a scent that signals unseen atmospheric shifts. Ancient folklore sometimes attributed sudden mists or unexpected showers to the whims of forest spirits, unaware of these fungal emissions. These tiny aromatic signals whisper secrets of the coming weather, a delicate dance between earth and sky. The cycle of life and death in a forest is a continuous loop, with fungi as its tireless orchestrators. When trees die, saprophytic fungi break down their woody structures, returning essential nutrients like nitrogen and phosphorus to the soil. This decomposition process releases carbon dioxide, but also replenishes the ground for new growth. Consider this a vast, slow-motion recycling plant where every fallen branch becomes raw material. Scientists are now studying how rising global temperatures might accelerate or inhibit these decomposition rates, creating complex climate feedback loops. The forest floor hums with this quiet industry, a continuous negotiation between decay and renewal. Even in the face of environmental shifts, the fungal kingdom demonstrates remarkable adaptability. Some fungal species thrive in extreme conditions, from polar ice to desert sands, suggesting their potential resilience against future climate changes. Their robust spores can endure long periods of dormancy, awaiting favorable conditions. Recent studies reveal how certain fungi can even help plants tolerate drought or heavy metal contamination, offering a biological buffer against environmental stressors. This symbiotic strength offers a glimmer of hope in the face of ecological uncertainty, though the full extent of this partnership remains an active area of research. You glimpse a quiet perseverance, a testament to life's intricate dance with its changing world. As you trace the intricate networks of mycelium that sustain forests, you also acknowledge the silent chemistry within certain caps. This subtle power demands careful respect. Many mushroom poisonings stem not from malice, but from mistaken identity, often confusing a toxic species with an edible look-alike. Even experienced foragers can make errors in the dappled light of the undergrowth. The initial symptoms of mushroom poisoning can mimic common ailments, delaying accurate diagnosis. This ambiguity often leads researchers to debate the precise mechanisms of action for less understood toxins, a quiet evolution of understanding. Some historical texts describe ancient remedies, yet modern science relies on precise identification and supportive care. You learn to read the subtle language of the forest, recognizing both its gifts and its quiet warnings. You feel the subtle touch of fungal chemistry, a quiet, practical elegance woven into daily life. Many distinct flavors in the mushrooms you taste arise from intricate secondary metabolites. These are not directly for growth, but rather the fungi's unique chemical signatures signaling their presence. Long ago, folklore often named these traces fairy handiwork, while artisans turned their scents and colors into ancient rites. Today, researchers still debate whether these complex molecules primarily serve as defensive weapons against microbial rivals, or perhaps they are subtle signals for cooperative networks, fostering alliances beneath the forest floor. Exhale, picturing leaf shade and slow rain. Let this exchange linger before the next quiet turn. You sense the forest thinking slowly in the dark, line by line, through these hidden chemical conversations. You recall the unseen networks beneath the forest floor, a silent language of threads. Now, imagine these intricate connections brought into human spaces. Soilless cultivation, the gentle art of bags, buckets, and blocks, allows mushrooms to flourish without Earth's embrace. It transforms humble materials into nutrient-rich homes, quietly engineering flavor and structure. You observe this elegant persistence in daily life. Simple measures guide the process. Hours until a cap unfurls, grams of spores released. Mycelium weaves its meters patiently through the substrate. It feels as though the forest lent threads to think slowly in the dark, line by line. These deliberate traces, once named fairy handiwork, now yield a steady harvest. Artisans learned to coax scents and colors from these quiet engineers. Exhale, picturing the subtle exchange within each block, a lingering whisper before the next quiet turn. You might walk across a field, seeing only green blades swaying. Yet, within many grasses, fungi weave their microscopic threads known as endophytes. These hidden partners protect plants from drought, disease, and insect pests. They form a silent shield within the plant's own tissues. Researchers still debate the true nature of these relationships. Are they purely cooperative? Or do fungi exact a subtle cost for their protection? It is a quiet negotiation over resources. Some endophytes even produce powerful alkaloids. These compounds make the grass unpalatable or toxic to grazing animals, a surprising defense mechanism. Such fungal chemistry has shaped herd movements across continents for millennia. It is a quiet, complex chemical warfare, unseen by the casual eye, profoundly influencing the landscape. Consider this vast, unseen world, influencing the very pastures where life thrives. It stands as a testament to fungal ingenuity. You might walk past a field, unaware of the subtle, persistent rust fungi at play on the leaves. A single wheat plant, if infected, can host billions of microscopic rust spores, each a potential new point of infection. Imagine a dusting of fine, rust-colored powder, each speck carrying an immense fungal blueprint. Researchers still actively debate whether these fungi are merely aggressive competitors for plant resources, or if their long coevolution hints at more intricate, ancient forms of interaction. They are engineers, in a way, reshaping plant defenses and nutrient flow, quietly directing the fate of entire harvests. Consider how these invisible threads of fungal life weave through our agricultural landscapes, a persistent, quiet force shaping what arrives on your table. You might not often consider the quiet work unfolding beneath your feet. In a single handful of forest soil, networks of fungal mycelium can stretch for meters, silently orchestrating the breakdown of fallen leaves and branches. These decomposer guilds, led by countless mushroom species, act as nature's intricate engineers, transforming spent organic matter into vital nutrients for new growth. Researchers still observe these unseen processes, often debating whether cooperation or competition primarily shapes their complex patterns in field plots. This slow, deliberate exchange of elements, once named fairy handiwork in folklore, now reveals itself as an elegantly persistent system. Imagine the forest borrowing these threads to think slowly in the dark, line by patient line, allowing this hidden activity to linger in your thoughts as the quiet rain falls. You have seen how the forest floor whispers its ancient stories through unseen threads. These patient networks, so often hidden, hold quiet secrets for human well-being. They touch daily life in persistent, gentle ways. Across continents, ancient healers learned to listen to the silent language of fungi, uncovering their deep medicinal properties. For generations, certain species became revered allies. Consider the reishi mushroom. Known in Asian traditions for calming the spirit and supporting vitality, imagine the forest floor as a vast, living pharmacy, where mycelial threads weave elixirs from soil's deep wisdom. In some folklore, a medicinal mushroom's sudden appearance was a gift from forest spirits. It was seen as fleeting fairy handiwork. Modern science now gently unpicks these ancient practices. Researchers seek precise compounds offering profound effects. They often debate the full spectrum of their subtle interactions. You might close your eyes and sense the slow, patient unfolding of nature's remedies, a quiet promise carried on the forest air. You have considered the unseen wisdom of the forest floor, where networks operate beyond our immediate sight. Now, picture an entirely different scale of fungal presence. A giant puffball, often resembling a ghostly soccer ball, can release trillions of microscopic spores. A single large specimen might eject 7 trillion spores, each a potential new life. This vast dispersal, like a silent explosive cloud, raises questions about resource allocation. Researchers still debate whether this abundant spore production primarily serves a competitive advantage, or if it fosters cooperative spread across diverse environments. You might consider the sheer volume of genetic material scattered by the wind. This quiet, persistent act ensures the mushroom's legacy, a subtle engineering of future landscapes. Beyond familiar caps and gills, you encounter organisms quietly redefining boundaries. Slime molds begin as single cells, then merge into a collective, almost fungal form to reproduce. Imagine a creature navigating a maze to find food, yet lacking a brain. A single times physarum polycephalum times cell might spread its network across your kitchen table, seeking oat flakes. Scientists debate whether intricate field patterns reflect competition or cooperation. You might see them as quiet engineers, sifting detritus, signaling nutrient pathways across decaying leaves. They orchestrate energy and matter, like tiny, living currents in the undergrowth. Their elegant persistence offers a glimpse into life's persistent ingenuity, unfolding slowly in the dark. You often find these silent architects clinging to ancient trees, their forms like miniature ledges. These bracket fungi, sturdy and resilient, offer a unique perch or even a nesting site for various forest creatures. A single large bracket can support the weight of a foraging bird, a testament to its dense, woody structure. Their hard, layered bodies act like natural balconies. They provide a stable platform where woodpeckers might rest, or even excavate a cavity for shelter. Some species grow so large and old, they become intricate multi-story homes. Imagine a living apartment complex built right into the tree's side, hosting insects and small mammals. These slow-growing structures represent years, sometimes decades, of patient decomposition. Consider the quiet life unfolding within these woody shelves, a testament to nature's intricate design. The forest holds many such subtle havens, waiting for you to notice their enduring grace. You might recall the quiet resilience of mycelial threads, silently weaving through the soil. This unseen persistence extends its influence, reaching into the vibrant heart of human communities. You notice how mushroom markets, often nestled in rural economies, touch daily life with a quiet, practical elegance. For many families, a single season's harvest of wild chanterelles or truffles can provide substantial income. This enduring value becomes a testament to their quiet presence. These fungi act as engineers of nutrients, signals, and flavor, transforming forest bounty into tangible sustenance and trade. Artisans once turned their unique scents and colors into rites, seeing them as fairy handiwork. Researchers still debate whether mushroom distribution patterns reflect cooperation among species or subtle competition for resources. You breathe in the earthy aroma, picturing leaf shade and slow rain. Let this exchange linger before the next quiet turn. You recall how life's quiet persistence finds its way into every niche, even where the forest floor gives way. This enduring spirit extends to the very edge of the land, where the ocean breathes against the shore. Along rocky coastlines, you discover resilient fungi, forming intricate lichens, clinging steadfastly to stone. These unique coastal finds thrive amidst the salt spray and tidal ebb, a partnership of fungus and alga, transforming raw elements. Some ancient cultures recognized their value, carefully gathering certain species for their mineral content. or as a famine food, a subtle flavor of the wild sea. These fungal partners, acting as silent architects, slowly etch patterns into the ancient rock, creating miniature ecosystems. Scientists still debate the full extent of their role in coastal nutrient cycling, a complex exchange often hidden by the waves. They offer a quiet testament to life's adaptability, a persistent, subtle presence at the ocean's edge, a slow, deep breath of the world. You notice how the hidden signals of the forest, once thought beyond human grasp, are often revealed through an unexpected alliance. For generations, the quest for underground truffles has relied on the extraordinary animal sense of smell. While pigs were historically employed, their natural inclination to consume the fungi often damaged harvests. Modern truffle hunters now overwhelmingly favor specially trained dogs, whose focused diligence and lighter touch ensure the delicate mushrooms remain intact. Specific breeds, such as the Lagotto Romagnolo, are prized for their innate scenting abilities, often beginning their training with playful scent-based games from a young age. This careful cultivation of a dog's natural talent transforms the hunt into a nuanced dance. A subtle shift in wind or an almost imperceptible scent trail guides the search. You might consider the quiet intensity in the dog's soft snuffling, a dedication echoing through the dappled light of the forest. You learn to recognize the quiet ways mushrooms weave into daily surroundings, often unnoticed until a moment of gentle concern arises. The vast majority of mushroom encounters pose no threat, yet a small fraction of species carry compounds that demand careful attention, especially when curious, small hands or paws are near. This quiet vigilance, much like an ancient forest's slow growth, ensures the well-being of the most vulnerable. Researchers continually refine identification guides. They understand the subtle variations in form and color that distinguish a harmless cap from a potent one. It is a persistent, gentle education, recognizing the forest's borrowed threads in your own garden or local park. This awareness allows you to navigate the fungal world with peace, letting the exchange linger before the next quiet turn. You have felt the quiet presence of fungi in the forest, their threads reaching into the soil. Their subtle touch extends even to the most refined human crafts, shaping flavors you cherish. Consider Time's Botrytis cinerea asterisk, a fungus often seen as a blight, yet holding a unique transformative power. Under specific, delicate conditions, this gray mold becomes noble rot, a coveted partner in winemaking. It gently perforates grape skins, allowing water to evaporate and concentrating sugars. This fungal alchemy deepens flavors, adding notes of honey and apricot. You taste a direct expression of the vineyard's unique terroir, a delicate dance between decay and creation. Such quiet collaborations reveal how fungi sculpt our world, one exquisite drop at a time. As you contemplate the persistent, unseen work of fungi, their true scale can defy common perception. Deep within Oregon's Malheur National Forest, a single organism stretches across 2,200 acres. This vast network of thymes, Armillaria ostoiae asterisk, known as the humongous fungus, holds the record as the largest living organism by land area. Imagine a subterranean forest, its roots not of wood, but of fungal threads, silently weaving through the earth. Its sprawling mycelial mat, hidden beneath the surface, would cover roughly 1,665 football fields. Scientists estimate its age to be between 2,400 and 8,650 years, a timeline speaking of ancient persistence. While you only see the golden honey mushrooms fruiting above ground, these are merely the visible tips of a vast, ancient empire. This silent, slow expansion redefines what you might consider a single life. A hidden giant breathing beneath the forest floor. You might perceive the forest as a collection of trees, yet beneath your feet lies a hidden architecture. It is here that fungi, the silent engineers of mycoforestry, manage the woods with an intricate touch. Imagine how specific fungal species, when introduced to a struggling forest, can extend their mycelial networks for many meters in just weeks. These vast underground systems then deliver vital nutrients and water to young saplings, boosting their survival rates by as much as 40%. Researchers still debate the dynamics of this complex web. Does it operate primarily through cooperation, sharing resources generously, or does subtle competition also shape its intricate patterns? Folklore once named these fungal traces fairy handiwork, seeing only magic, where intricate biological processes quietly unfold. You watch the leaf shade, aware of the persistent, unseen exchange beneath the soil. A deep, silent breath. You might not always notice the quiet work of fungal cultures in your kitchen, yet their elegant persistence shapes many foods we cherish. These microscopic architects, part of the wider mushroom kingdom, transform raw ingredients into stable, flavorful provisions. They act as natural engineers, breaking down molecules to create new textures and aromas. Extending shelf life. Scientists observe this delicate balance, still debating if their community dynamics lean more towards cooperation or subtle competition. Folklore once named these intricate transformations fairy handiwork, while artisans turned simple ingredients into complex rites of flavor and preservation. Consider the aged cheese or cured sausage. It is a slow thought from the forest. Borrowing threads of time, you feel the quiet exchange linger, like cool air under leaf shade. Before the next gentle turn, you begin to sense the quiet agreement between humans and the hidden fungal networks. Consider how a single handful of forest soil might cradle meters of mycelial threads, silently engineering nutrients for vast ecosystems. This intricate web, often fruiting for mere hours, demands a mindful approach to harvest, respecting its habitat and life cycle. Ancient folklore once whispered of these delicate traces as fairy handiwork, imbuing them with a sacred quality. Today, researchers still ponder if cooperation or quiet competition truly defines these subterranean patterns in field plots. Exhale now, picturing the dappled leaf shade and slow rain. Let this deep exchange gently settle before the next quiet turn. You might find yourself drawn to the forest at dusk, seeking an ethereal glow. Certain fungi, like thyme's Mycena chlorophyos thymes or foxfire, emit their own light, illuminating the undergrowth with a soft, green hue. This natural phenomenon, often a silent beacon in the dark, guides creatures and sometimes even human visitors, offering a glimpse into the forest's hidden pulse. For centuries, folklore attributed these faint, glowing patches to fairy handiwork or spectral presences, weaving tales around the forest's hidden lanterns. Today, these living lights inspire bioluminescence tourism, where you walk trails lit not by electricity, but by the quiet, elegant persistence of mycelial networks. It feels as though the forest borrowed threads to think slowly in the dark, line by line, creating these luminous pathways. Researchers still debate the exact purpose of this glow, whether it attracts spore-dispersing insects or deters predators. You feel the forest breathing slowly around you, a silent exchange of light and life, a gentle reminder of the unseen world. As you consider the vast unseen networks beneath our feet, imagine how these silent architects also weave themselves into our tales. In countless stories, from ancient myths to contemporary cinema, mushrooms symbolize hidden realms and profound interconnectedness. They often represent the subtle dance between decay and rebirth, a constant cycle of transformation. You might recall the forest floor, where mycelial threads seem to borrow silence. They think slowly in the dark, much like an author plots a complex narrative, line by line. Folklore once painted their sudden appearances as fairy circles or magic portals. These were the mischievous work of unseen hands, giving rise to countless legends. Even today, filmmakers use their diverse forms, from towering fungal forests to microscopic spores. They evoke wonder, mystery, or a primal sense of the unknown, shaping our collective imagination. Let this gentle exchange linger as you drift towards the next quiet turn in the forest's slow, dark thought. You might find mycelium quietly shaping spaces around you. Imagine walls grown from fungal threads, offering insulation and strength. These living materials can be molded into blocks or panels. They are light, yet surprisingly durable, transforming how you build in human-scaled ways. The main subject acts as an engineer of shelter, not just nutrients, creating quiet, resilient spaces. Researchers debate if cooperation or competition best explains the intricate patterns recorded in field plots of these growing structures. Yet, folklore once named these subtle traces fairy handiwork, a testament to their hidden artistry. You might even measure their growth in simple terms. Consider the hours to fruit, grams of spores, or meters of mycelium in a handful of soil. Exhale, picturing leaf shade and slow rain as these quiet threads continue their persistent work. You might consider how the forest floor holds countless secrets, some too subtle for the eye. Among these quiet influences, fungi are master chemists, crafting compounds that awaken new dimensions of taste. They gift us umami, a savory depth, and kokumi, a nuanced richness that amplifies other flavors. Scientists observe how specific amino acids and peptides from mushrooms bind to taste receptors, creating a lingering satisfaction. This isn't merely a flavor, it's a subtle architectural principle for the palate, building bridges between tastes. While umami is widely understood, the precise mechanisms of kokumi, often described as mouthfeel or fullness, remain an active area of research, a quiet debate unfolding in laboratories. You feel this quiet persistence in a warming broth, a complex layer added by the unseen hand of fungi, inviting a moment of slow savoring. Recalling the quiet persistence of mycelial networks, you trace their influence far beyond the forest floor. These intricate fungal pathways, often unseen, form the very foundation of farm-to-table mushroom supply chains. They deliver essential nutrients and distinct flavors directly to your plate. Imagine how a single gram of spores initiates a vast network, stretching meters of mycelium through substrate in mere days. Such rapid growth is a quiet marvel of biological engineering, transforming humble organic matter into culinary delight. Folklore once whispered of fairy handiwork shaping these ephemeral fruiting bodies. Modern growers meticulously manage conditions, echoing ancient artisans who valued their unique scents and colors. Researchers still ponder whether the mycelial world operates on pure cooperation or subtle competition for resources, a debate playing out in every cultivated bed. You might picture leaf shade and slow rain, letting this hidden exchange linger, a testament to nature's quiet, persistent elegance. You once considered the forest a silent library, its stories whispered through rustling leaves. Now, new methods allow us to read the very language of its oldest inhabitants. Through genome sequencing, scientists are unearthing an intricate history written in fungal DNA, revealing countless previously unknown lineages. This genetic blueprint maps out relationships and adaptations across vast stretches of time. Each sequenced genome acts like a blueprint for a tiny, living engineer, detailing how mushrooms craft nutrients, send signals, or develop unique flavors. Researchers often debate whether these genetic patterns primarily reflect ancient cooperation or intense competition within their hidden networks. It's as if the forest itself is slowly revealing its internal logic, thread by delicate thread. These quiet discoveries reshape our understanding of life's interconnected tapestry, inviting you to imagine the unseen threads that bind our world. You sense the quiet persistence of life, an elegant thread woven through time. Cryo-storage allows us to safeguard fungal cultures, preserving their intricate blueprints for future generations. These frozen archives hold the genetic potential of mushrooms, crucial engineers of nutrients, signals, and flavors across countless ecosystems. Imagine the forest, borrowing these threads to think slowly in the dark, line by line. Ancient folklore once named such delicate traces fairy handiwork, a whisper of unseen labor. This careful preservation ensures we can continue to study their mycelial networks. Researchers still debate whether cooperation or competition best explains patterns recorded in field plots. You exhale, picturing leaf shade and slow rain, letting the exchange linger before the next quiet turn. You might notice how the quiet lessons of fungal life now gently unfurl within school classrooms. These lessons often frame mushrooms as engineers of nutrients, signals, and flavor in human-scaled ways. Students learn to measure hours to fruit, grams of spores, or even meters of mycelium in a handful of soil. It feels as though the forest itself lends its ancient threads, allowing young minds to think slowly in the dark, line by line. Folklore once whispered of fairy handiwork in such subtle traces. Researchers still quietly debate whether cooperation or competition best explains patterns recorded in field plots. Exhale, picture leaf shade and slow rain. Let the exchange linger before the next quiet turn. You notice the quiet, practical persistence of life, especially in extreme places. Consider thermotolerant fungi in hot springs, where mineral-rich water boils. Their elegant persistence touches daily life, often unseen. These fungi act as engineers of nutrients, signals, and even subtle flavors. Their mycelial networks can span meters in a handful of soil, a hidden architecture. It feels as though the forest borrowed these threads to think slowly in the dark, line by line. Researchers still debate whether cooperation or competition best explains their patterns. Folklore once named these traces fairy handiwork. Artisans turned their scents and colors into rites. Exhale, picture leaf shade and slow rain. Let this quiet exchange linger. You consider the quiet art of preservation, a gentle pause in nature's cycle. When harvested, many mushrooms thrive in cool, dry conditions, extending their delicate existence. Refrigeration slows their metabolic processes, delaying the enzymatic breakdown that leads to spoilage. This simple act mirrors the forest floor's own cold breath, where mycelial networks persist, waiting for ideal conditions. Researchers still debate whether these dormant networks operate through cooperation or competition in their subtle engineering of soil nutrients. For centuries, quiet observations of such fungal persistence inspired tales of hidden forest magic, a fairy handiwork in the dark. This patient waiting, a silent conversation between life and stillness, allows their unique flavors to linger longer for you. You often encounter the quiet challenge of keeping fresh mushrooms, their delicate forms tucked into packaging. This daily act of containment generates a significant portion of produce waste, with billions of plastic containers used for these fungi globally. Researchers now explore biodegradable films and mycelium-based trays, transforming the very threads of the forest into new, earth-friendly materials. This innovation mirrors mycelium's quiet persistence, always seeking new pathways, even in darkness. The shift towards less wasteful packaging becomes a silent conversation between human ingenuity and nature's elegant solutions. You might feel a gentle breath of the forest in each mindful choice. Across kitchens, coastlines, tundra paths, and cedar shade, the journey through the world of fungi leaves a soft signature. You recall the rings in grass, the perfumes in soil, and small lanterns glowing on fallen logs. The trail loops back to dawn, to those dew-bright circles that once looked like thresholds in old stories. Now, they feel like pages in a living atlas, each detail a quiet revelation. You keep the image of hyphae meeting roots, understanding that health truly travels on unseen threads. Droughts are eased, seedlings ushered, and nutrients returned to a common table through this ancient network. Numbers helped us glimpse the scale: grams, meters, hours. But the true feeling is slower than arithmetic. It is a cadence of rain and wood and breath, a quiet rhythm beneath the forest floor. It is as if the forest were thinking aloud, and the ground answered in a whisper of spores. What else might appear if you listened longer? What patterns wait at the edge of light, between the heartbeat of storms and the hush afterward? If your eyes grow heavy, let this vast, unseen lattice gently hold you. If your thoughts wander, follow a single white thread until it opens into cool, deep shade. If the night deepens around you, keep that soft glow of leaf light close. Rest now. Let the soft exchange continue beneath you, steady and unseen. Let the soft exchange continue beneath you, steady and unseen. Let the soft exchange continue beneath you, steady and unseen. Good night.